Hello and welcome to this session. In today's session, we will explore the fascinating world of temperature measurement sensors. Understanding the principles and applications of different temperature sensors is essential for ensuring accuracy, reliability, and safety in countless processes and systems.
Objectives. At the end of this session, you will be able to identify the different types of temperature sensors such as RTDs or resistance temperature detectors, temperature sensor ICs, thermocouples, platinum resistance sensors, thermistors, and thermostat sensors, and identify the different parts of temperature sensors. Let's first review the working principle of temperature sensors. Temperature sensors are designed to detect temperature changes by converting heat energy into electrical energy. They receive input information directly or indirectly from their surroundings and convert them into electrical signals for further processing. This electrical output is then used to operate industrial machinery or equipment to control the temperature regulation. Let's now see the types of temperature sensors. The types of temperature sensors that we will look into are RTDs or resistance temperature detectors, temperature sensor ICs, thermocouples, thermistors, and thermostat sensors. Resistance temperature detectors or RTDs. Resistant temperature detector or RTD is a type of sensor that measures temperature by changes in electrical resistance. This sensor is known for its high accuracy. It can be used for its long service life and is very stable in its functioning. The types of RTDs are wire wound RTDs, thin film RTDs, and coiled RTDs. Wire wound RTDs. This type of RTD consists of a coil of fine wire, typically made of platinum, wound around a ceramic or glass core. Wire wound RTDs offer good stability and accuracy over a wide temperature range. Thin film RTDs. Thin film RTDs use a thin layer of resistive material, usually platinum, deposited onto a ceramic substrate. Thin film RTDs are commonly used in applications requiring fast and accurate temperature measurement. Coiled RTDs. Coiled RTDs consist of a platinum wire wound in a helical coil pattern around a ceramic or glass core. This design provides a larger sensing surface area which can improve the RTD's response time and sensitivity to temperature changes. Applications of RTDs. RTDs are used in air conditioning and refrigeration servicing, food processing, stoves and grills, textile production, plastics processing, and petrochemical processing. Next, let us see temperature ICs. Temperature ICs are specialized components engineered for temperature measurement utilizing semiconductor materials. Essentially, they utilize semiconductor properties to translate temperature changes into measurable electrical signals. There are two main types of temperature ICs: analog output temperature sensors and digital output temperature sensors. Analog output temperature sensors. These sensors produce an output voltage or current that is directly proportional to the temperature. The benefit of this type is its simplicity but may require additional circuitry for calibration and signal processing. Digital output temperature sensors. These sensors convert the measured temperature into a digital signal, usually a binary code. They are more complex than analog sensors but offer greater accuracy, resolution, and ease of use with digital systems. Temperature ICs find widespread application across various fields, including in central processing units, CPUs, mobile phones, and industrial settings. They are particularly valuable in environments where precise monitoring of temperature sensitive components is essential for optimal performance and safety. Let's now see the thermocouple sensor. Thermocouples are sensors used for measuring temperature based on the principle of thermoelectric effect. Thermocouples are widely utilized across various industries and applications, including industrial ovens, food processing, furnace control, and environmental monitoring. There are different types of thermocouples used for different applications with respect to voltage and temperature. Thermocouples don't have an operating voltage themselves. They generate a small voltage output based on the temperature difference between the hot and cold junctions. This voltage is measured by a temperature reader and converted to a temperature reading using a reference table. There are three types of thermocouples: type J, type K, and type T. Type J, they have a temperature range from 0 degrees Celsius to 750 degrees Celsius. This is a common and cost-effective option but not ideal for high temperatures. Type K, temperature ranges from minus 200 degrees Celsius to 1250 degrees Celsius. This is the most widely used thermocouple due to its wide temperature range and good corrosion resistance. Type T, its temperature ranges from minus 250 degrees Celsius to 350 degrees Celsius. This is suited for lower temperature applications and offers good accuracy but has a limited range. Let's now see the thermistor sensor. A thermistor sensor is a type of sensor that utilizes a thermistor, a temperature-sensitive resistor, to measure temperature changes in its surroundings. They include bead type, probe type, disc type, and screw type. Thermistors are made of semiconductor materials such as ceramics or polymers, and their electrical resistance changes significantly with temperature variations. Thermistors offer advantages such as high sensitivity, small size, and low cost, making them versatile sensors in various industries and applications. Thermistors typically operate at low voltages, often in the range of a few volts. Thermistors are available in different types with varying temperature ranges. Common ranges include standard thermistors, typically operate in the range of minus 55 degrees Celsius to plus 150 degrees Celsius. High temperature thermistors, they can operate up to plus 300 degrees Celsius or higher. Low temperature thermistors, they operate in the sub-zero temperature range, sometimes down to minus 100 degrees Celsius or lower. Thermistors are widely used for temperature measurement and control in various applications including HVAC systems, automotive industry, medical devices, and consumer electronics. Let us look at thermostat sensors used in the geysers. Inside the geyser, there is a wool called glass wool. It is also known as fiberglass insulation. Inside the glass wool, there is a tank made up of stainless steel which helps in storing the water. Downside of this geyser, there are thermostat sensors. Once we open the tank, we can locate the thermostat sensor inside the tank. Thermostat monitors the temperature of the water inside of the geyser tank. When the water temperature falls below a preset level, the thermostat activates the heating element to raise the temperature back to the desired level.
This brings us to the end of this session. In this session, we have learned to identify the different types of temperature sensors such as RTDs or resistance temperature detectors, temperature sensor ICs, thermocouples, platinum resistant sensors and thermostat sensors, and identify the different parts of temperature sensors. Thank you for watching. We will see you in the next session.